This is a review for the Unit 6 test. One part of the test is to solve expressions when given values for the variables. So in these expressions, in all of them, y will be equal to 5 and x is going to be equal to 9. So simply, we just take the value. For example, y is 5, we're going to put it where we see the y, and then solve that problem. So rewriting it, we would get 3 plus 5 will equal 8. And this is the answer I would be looking for. Okay? Now, remember, when you have something like 3y, that is multiplication. When you have a number next to a variable, remember this number is called the coefficient, that is a multiplication problem. Okay, so why don't you take a few minutes, pause the video, solve the other 5 problems I have here, and then I'll come back and give you the answers. Okay, so working to number 2, once we substitute our 5 in, we will get 5 plus 8 equals 13. On number 3, again, we said that that was going to be multiplication. So it is 4 times 5, 20. Down to number 4. Remember that this is an exponent, so that means it's going to be 5 times 5 plus 9. Following our order of operations, this comes first. So we have 25 plus 9. And then once we add those, we would get 34. Number 5, again we see multiplication. 300 times 5. And that would give us 1,500. And finally, we have an exponent again. So x to the second power is 9 times 9 minus 2 times 5. Here you need to be very careful you follow the order of operations and do all the multiplication first. So we have 9 times 9, we get 81. Minus 2 times 5, we get 10. 71. Okay, there is some vocabulary that we need to know for this test. The first is a term. It's part of an expression, and they are separated by addition and subtraction signs. For example, in the expression, 3n plus 7b minus 5, there are 3 terms. 1, 2, 3. Even though this has a 3 times n, there is an operation there, it's a single term. The terms are separated only by addition and subtraction. Okay? So something like b over 5 minus 4 times 11, again, remember, it's just the plus and minus sign. So here's our dividing between terms. This is a single term. This is multiplication, so that is a single term. So this expression would have 2 terms. A coefficient, that is the number multiplying the variable. So if I had 3b minus 11, my coefficient is just the 3. Not the b, just 3. In a single variable, a plus 17, the coefficient of a, since there is nothing there, we say that that coefficient is 1. Okay? Lastly, we have a constant. Constant is a single number being added or subtracted and has no variables attached to it. So 3x minus 2y plus 4, constant, just the 4. Being added, it has no variables, that is our constant. You will need to be able to identify these on the test. Okay, now we're going to move on to combining like terms. When we combine like terms, we find terms in an expression that have the same variable or they don't have the variable, and combine the ones that look the same. So in the first one, we always circle 4b. Then circle anything with a b in it and circle the sign in front of it. So this is a plus b. Together, a 4b plus b, we have 5b, and then we have a plus 12. This would be the simplified expression by combining the like terms. On the second one, we'll start with our 6f. And over here we have a 2f, but don't forget to circle that minus sign because that tells us if we're adding or subtracting. 6f minus 2f is 4f. Now we're going to use this sign for the next operation. And we have a 7w, I'll draw a box just so they're different than the circles, plus w, that's 8w, and all we have left is this plus 6. For our third example, 2c plus 2c, 4c. Here we're going to use this symbol. 14 minus 9 is 5. And then lastly down here, b plus b plus b, 3b plus 10 plus 10 is 20. Okay, now here is another important step. The difference here is we have some of them that have exponents. It's important to remember that when a variable has an exponent, it is different than that same variable without the exponent. Think of it as a completely different variable. So we'll start with x. We ignore these two because they're to the second power. And we have plus 7x. That is 8x. So we're going to bring down this plus. 4x to the second power plus 2x to the second power is 6x to the second power. Okay, one of the other parts of our test is using the distributive property to create equivalent expressions. Whenever you see a number on the outside of the parentheses, we know that that's multiplication. We can change it to an equivalent expression if we multiply that number times each term inside the parentheses. So, in our example, we have 3 times 2y is 6y. We're going to use the plus sign because that's what the original problem had. And 3 times 1 is 3. They're both equivalent. Let's try our next one. 4 times y, 4y, plus 4 times 1, 4. Go ahead and try the other 3, and I'll come back and let you know if you got them right. Okay, so hopefully when you distribute 5, you ended up with 10y plus 15. On our next example, distribute 3, we would get 12y plus 18. And lastly, here we only have one number to distribute it to, 32y. Okay, so now that we've done using the distributive property, what about if we have an expression, we start with this, and we want to get back to this one? Well, we have to look at our terms and find a common factor for each of these terms. So in the example here, we have 6y plus 3. What is a common factor of 6 and 3. Well, a common factor is 3. So we're going to divide both of them by 3. So we're going to put our 3 on the outside in our parentheses. Now we're going to divide each of these by 3 and put the result inside. So 6y divided by 3 is 2y plus 3 divided by 3 is 1. And there you have it. Okay, go ahead and try to use factoring by finding a common factor and create an equivalent expression for each of these. And I'll come back. All right, so common factor of 4 and 2 in our first example would be 2. That goes on the outside. Dividing each of these terms by 2, we get 2y plus 1. On our second example, a common factor we could use is 3. And the resulting quotients would be 2y plus 3. And lastly, a common factor is going to be 5. So we end up with y, or 1y, plus 2. Okay, now there's going to be some occasions where you can have more than one correct answer. For example, in this problem, 20x plus 30y, they have more than one common factor. One that comes to mind right away is 10. So if I put a 10 out here and divide each of these by 10, I'm going to get 2x plus 3y. Can you come up with any other answers? Pause it now, try a few, and I'll be back. Okay, another example is if dividing by 2. We could get 2 times 10x plus 15y. Could also divide by 5. 5 times 4x plus 6y. Now this is important because I do know I have a couple of questions on there where I'm asking you to figure out which of the following will be equivalent to a given expression. So keep in mind that there is more than one way to do this. Good luck on the test.